Now I want to show where how do you handle issues in your design and figure out what you actually need to apply the contact sets to. So let's go, let's do something a little bit more common. So I'm going to right click on connections and I'm going to add back in that global contact that we normally would see when we come in. Normally it's bonded. That's the default is a component contact, global contact that's bonded. I'm going to change it to no penetration because a lot of cases you don't want these two parts bond to each other, but you do want them to not penetrate through it. You want it to slide on the surface or move around a little bit as it deflects. So I'm going to go with that. And we're going to set this model up here, so no penetration there. Fixtures, so we'll do a fixed geometry. I'm going to do it on the bottom of this guy here. And we'll apply that. And I'm also doing a load here. Let's just do a pressure on this surface. We'll do 500 Newton meters squared. So we'll confirm that. All right. So obviously, if this is not bonded to here, then we should see this slide away. So let's see what happens if we. We'll just go with the default mesh here. Well, let me see here. Maybe we'll just call this mesh. From before we said 0.033 was what we expected. That was when we were twisting it. But anyways, we'll green check that. All right, so it looks good. So let's go ahead and run it now. Simulation and run. Oh, material, I didn't find the materials. Okay, so for twist 1 and twist 2, we'll just get the alloy steel again. Apply that to those. Now we should be able to run this. Looks like it's getting bogged down right here. So on purpose, I'm going to let this run the whole time so you can see what's going on here. So it says the iterative solver stopped. The solver has numerical difficulties. The model may not have adequate fixtures. No results saved. So it doesn't give you a whole lot of information. It took a little while for it to fail here. All right. So the thing I'm going to show you next, the strategies that are on the handout and what I'm showing you next are to help this thing fail and fail quickly, or work and work quickly. But it doesn't give you results that you should use in the end. And I'll explain what that means as we go here. So the first thing I want you to do is to go up here to the study, right click on it and go to properties. And I want to go down here to use soft springs to stabilize model. We talked about this before. I think this happened in ANSYS. Turn it on somewhat ready. But what this does is it connects soft springs to every single node in our model when it runs the simulation. So these soft springs allow things to move, but not move too much in a way, so that basically if they're flying away, it'll still solve it, but it won't be the right results, but at least it gives you something that hey, here's your issue. You can see what's moving and what's taken off. So we'll click OK there. So use soft springs to stabilize the model. And the other thing we do is go over here to mesh. Right click on mesh, create mesh. And the big thing is come down here advanced. And you want to use draft quality mesh. The whole reason for draft quality mesh is, again, we want this thing to fail. We want it to fail quickly. So the whole draft quality is to be, just do what needs to be done to get this thing to solve or fail quickly. All right, so that's what we want to see happen here. So we'll see our mesh here, but we already gave it some parameters on the mesh side. So I want to see if we come back in here. If we take the mesh parameters off here, still got the draft. No, so it's still showing up there. But it will help in the process of speeding things up here. All right, so let's go ahead and run this. See how long this takes to run. I think it was about 43 seconds last time. All right, so excessive displacements were calculated in this model. So that's telling you something is really moving a lot. We'll just say no, solve it with small displacement. And, oh, it disappeared. All right, so let's look at our displacement plot. So our displacement is 5.6 times 10 to the 4th millimeters. So something's taken off here. These pieces are not a meter. They're very, very relatively small. So that piece flew away. I don't know where it went. Let's bring that piece back there. All right, but one of the things you can do to see it is you can edit definition and go, instead of true scale, let's go with automatic, and you see what it's at, 0.0006. And, well, there's the part, right? So the whole part's just taken off because there's nothing holding it where it should be. All right, so using those techniques, the soft springs and the draft mesh are two key things that if your model's, I would, unless you're confident it's going to be working the first time with the setup you have, I would even run that even the first time just to make sure everything looks good. But yeah, it's probably good just to run with what you guess, your basic conditions, a good mesh, and then if it does fail, come back, use the soft springs, and use the draft mesh so things can fail quickly, and you can get some information about what's going on. Hopefully things are just flying away. You need to lock them in a little bit more with the fixtures. All right, so that's what I had in this presentation. If you have any questions, put them in the comments below, and I hope to see you next time.